Okay, in this video, we're going to show you how to solve a system of linear equations algebraically by using the substitution method. Now, you may have already seen another video in which you solve the system of two lines by graphing both lines and then finding where they intersect. And that's called the graphing method. But today, we're going to actually solve specifically for that point where the two lines cross. Okay, now here you'll see 5 steps to our method, and you may actually want to pause the video right now and write down these steps so that you can have them in your notebook when you're doing your work. But basically, we're going to look at both equations. We're going to pick one of the equations, and we're going to use that equation to solve for one of the variables. So notice that that is our first step. Do you see that? So we're actually going to do that now with this example. So as we go through the examples, we'll go through the steps so that you can see how the steps relate to the example. Okay, so I've got example A here, and I've got a system of linear equations. They want us to solve it by substitution. I went ahead already and kind of put these green numbers here. I put those there just to tell you that the first equation is equation number 1, and then we're going to let this bottom equation be equation number 2. So notice how we do have two lines in standard form. You may be familiar with slope-intercept form of a line. That's where you have the y equals mx plus b, or you have the equation solved for y. But you notice that these two happen to be in standard form, so the x's and the y's are together. Okay, but what I want you to do is look at both these equations because we need to pick one of the equations to solve for one of the variables. And you know what? Make it easy on yourself. Okay, usually here's what I recommend. If you have one of the variables with a coefficient of 1 already, so that means you have a variable somewhere in your system that is all by itself with no number in front of it, then use that equation and solve for that variable. So as we look here, equation number 1 has one of the variables all by itself. Can you see it? It's variable y, right? It's all by itself. The x has a 3 in front of it, so it's not by itself. And this x in the second equation has a 2 in front of it, coefficient of 2. And this y has a coefficient of 5. So these are not alone, right? But this one, this first equation, it has the y by itself. So that's the equation that we are going to use first. Now, here's what I want you to do. On your piece of paper, right down the middle of the piece of paper, I want you to draw a straight line going back and forth, okay? So I'm sorry, up and down is what I meant. So just draw a straight line. All right. Yeah, mine's not too straight. Okay, but there you go. So you want to separate your piece of paper into 2 halves, okay? And then on the left half, I want you to rewrite the equation that has the variable by itself. So that's for us in this particular example, that would be equation number 1. So we're just going to rewrite it on the left. Okay, so 3x plus y equals 1. That equation goes on the left. And then all right, so the second equation goes on the right-hand side. So you just want to rewrite it there for yourself. Okay, so that's what I'm doing here. 2x plus 5y equals 18. So the equation that we're going to solve for the variable by itself, it's on the left. The other equation is on the right. Okay. Now you come over here to this equation on the left, and we want to solve for y, which means that we want to get rid of the 3x. So we're going to subtract the 3x to move it over to the other side. Okay, so subtract 3x, subtract 3x. Now over here, these are not like terms, so I'm going to rewrite this as y, because right, these add up to 0. So then I have y equals, and then I always like to have the x in front. So let's put the negative 3x first, and then plus 1. So now you have done step number 1. Step number 1, if you recall, let's move up here, was solve one of the equations for one of the variables. So you just did that here. Okay. Now it says substitute that expression into the remaining equation. So that's what we're going to do. So basically what I want you to do now is go to the right-hand side And on the left, we are solved for y. So I want you to locate the y on the right-hand side. And I want you to rewrite the equation, but instead of that y, I want you to put a set of parentheses, kind of like a placeholder. So it's going to look like this. So 2x plus 5, whoops. And then I want you to open a set of parentheses where the y is, right? And then just rewrite equals 18. So you're rewriting the right-hand side, but you have a set of parentheses holding the place of the variable that you're going to substitute, and that variable relates to this variable on the left, which is y. Okay, so now we're going to look on the left, and y is equal to negative 3x plus 1. So take that right-hand side of that equation, so that negative 3x plus 1, let's change colors here so you see what I'm doing. So that negative 3x plus 1, I want you to move it over to the right-hand side and put it in that placeholder you left for y, right? Instead of y, we're going to use negative 3x plus 1. So write it in, negative 3x plus 1. Okay, so now you have the equation on the right-hand side, but there's no y's at all. Do you see that? You only have one variable, which is awesome, because that means you can solve it. So that's our next step. Step number 3 is, step number 3 is solve the remaining equation. All right, so that's what we're doing. Okay, well now, if you said that we need to distribute here, you are absolutely right. It's looking like we're going to distribute the 5. So let me bring this down. So that's 2x plus, and then 5 times negative 3x is a negative 15x. 5 times 1 is a positive 5 equals 18. Okay, add these together, like terms, negative 13x plus 5 equals 18. Okay, so we're solving for x, so subtract 5. Subtract 5, we get negative 13x equals 13, and divide by negative 13. Okay. Oh, let me see if you can. I better scroll down. All right, so there you go. So now we have over here x equals negative 1 when we do this division. X equals negative 1. So what's happened? You've solved for the first coordinate of that order pair where the two lines meet, where they cross. The x value is going to be negative 1. So now we need to find the y value. So that's step number 4. Substitute the solution into the other equation to determine the value of the other variable. Okay, that's what we're going to do. So now what you do is you're going to bring this x equals negative 1 back to the left-hand side of your paper where you have that other line waiting, right? Remember? Okay. So now you're going to take this x equals negative 1, and now you're going to substitute it back up here in this x. So now you have y equals negative 3, and then instead of the x, you're going to use the x you found on the right, negative 1 plus 1. Fabulous. Okay, then look, you could just solve here. So negative 3 times 3. So 3 plus 1, or y equals 4. So what you found is that the two lines intersect at the point negative 1 for x, 4 for y. And that's what number 5 says. The solution to the system is the intersection point of the two equations, and it represents the coordinates of the order pair. So this is where those two lines intersect.